Perfect.
Yeah.
So, hello once more. So, I will talk today about transdisciplinary research designs, which are designed for air pollution mitigation. The agenda is, firstly, I will talk about the importance of air quality and why you should listen to me. Secondly, we will talk about what are the effective scientific methods. Then I will go into exact methods that we have applied, how to set up citizen science approach effectively for knowledge transfer. And I will also talk about how to combine two sustainability methods. They're called follow the innovation and transforms methods for institutional change. And I will sum up with recommendations for research based on two projects, VT Impact and DAME-BC. Why is air quality such an important topic? So air pollution damages our health and the environment. It's caused mainly by economic activities such as industry, transport, energy, and agriculture, as well as some domestic household activities like heating. The air is cleaner today than it has been for the last 2 decades. Policy actions and international cooperation have successfully reduced air pollution significantly. More action is needed still to make further progress. Fine particles and ground level ozone still create serious health problems. Emissions continue to harm many natural environments. And air pollution ignores national borders. It can be carried very long distances by the wind, so it needs to be tackled through cooperation at European, international, and global level, combining various expertise and stakeholders' know-how. So projects employing awareness building and transdisciplinary research can contribute to better air quality, and I would like to talk about these today. Why should you listen to me? The Leibniz Institute for Tropospheric Research is a member of the Leibniz Association in Germany. The institute was founded in 1992 to investigate the physical and chemical processes in the polluted troposphere. We are a German state-funded research institute. Tropos conducts field studies in several polluted regions parallel to the development of analytical methods for aerosol and cloud research. These tools are not only applied in field experiments, but also in extensive laboratory investigations, which form a second major activity. A third and equally important approach consists of the formulation and application of numerical models. This is mathematical climate modeling. My name is LiinaTõnisson. I work as a scientific coordinator at Tropos Directorate. I will present in the next minutes methods for conducting sustainability research based on transdisciplinary Tropos work. I will today present no air quality measurement results. All publications of ours where results are mentioned are noted on the slides. So if you want to know the exact measurement results, please check the publications. I will use this time to explain the methods we used because you can Google air quality values, but you cannot Google the insights we have from setting up transdisciplinary sustainability projects. This is our building. This is our institute. And based on our expertise, I will talk about effective scientific methods for air pollution mitigation. First of all, you need to know for what are you doing your research for? Who is your target group? And what do you want to achieve? Based on who is your target group and what is the purpose of your study, you can design your research design. It is very hard to have one fits it all strategy. So therefore, sometimes you need to combine several methods to meet the purpose, the goal of your study. The first thing I would like to talk about is citizen science that has been proven to be effective at our institute. The target group there, the participants are citizens, and what you want to achieve is behavioral change. citizen science throughout Europe is an important part of aspiring to the knowledge production to become more democratic. And it's stressing on the societal relevance of publicly funded research. Citizen science is making research public. Working with non-scientists is a two-way process where both sides, researchers and the public, learn something, but definitely serves the goal of knowledge creation, awareness building, and systematically testing the difference between believing and actually knowing. The second approach that I will talk about today is follow the innovation and transfer methods combined. And this works if you want to achieve institutional change. This is much more complex because if you have several target groups and your study has several purposes, you should first of all start by listing them. And in follow the innovation and transform methods, it was important to reach out to governments, NGOs, industry, and the purpose of the study was better policies, public engagement, as well as education, and greener transport solutions. Therefore, you can see that this is a much more complex set of goals and target groups and requires two different methodologies combined. Transform itself integrates backcasting and forecasting and goal setting, and follow the information. It's a knowledge co-creation methodology. I will come back to both of them immediately. How to set up citizen science effectively for knowledge transfer. So in Tropospheric Institute, Leibniz Institute for Tropospheric Research, we had a project called VT Impact. And from spring 2019 until winter 2021, we were crowdsourcing air quality sensing network out to about 100 volunteers. This was established in Leipzig, Germany, and the project aimed for knowledge transfer and knowledge co-creation. This project focused on volunteer mobile measurements with scientific instruments. Each volunteer was given a sensor backpack and asked to carry out measurements in the greater Leipzig area every day. And when we started this project, we thought how to motivate people to take part, because carrying out measurements is a time-consuming process. So we can't expect them to do hours of measurements without them really relating to the work that they're doing. So we started thinking how to get them engaged. And we found out that you need to have relevant, high quality data. And you need to think how to get them relate to the topic that you are investigating. Direct support needs to be provided on all stages. And they need to link their data to their observations. They need to have the aha effect. What can citizens relate to when it comes to air quality? So, soot is a carbon particle resulting from the incomplete combustion of hydrocarbons. Its color is black, therefore it's called black carbon. This is one of the things that everyone knows from the media and is something that citizen can relate to. The other thing is particulate matter, the first point on the slide. It contains microscopic solids of liquid droplets that are so small that they can be inhaled and cause serious health problems. Some particles less than 10 micrometers in diameter can get deep into your lungs, and some might even get to your bloodstream. This has bad health effects. Once again, this is something that a citizen can relate to. Black carbon and particle number and mass concentration pollutions, they remain high in city centers. Citizens are most probably affected and therefore can relate to the problematic, are more motivated to carry out the measurements. So if you want to target citizens, you need to know they are non-scientific people who might not be able to maneuver the most complex measurement kits. Therefore, if over-the-counter sensing technologies are not there, you can't buy them, order via eBay for your target group, you might consider creating your own. And this is what we did. And this often will be the thing that you will have to do based on all the wide range of citizen science projects done in Europe. What was very important for us when we started designing our technology was that it's easy to use. The user interface has to be something that you can grasp. So the backpack was operational just with one switch and one USB charging cable, and it measured the PM and black carbon BC concentrations. The backpack itself consists of an isothermometer, it's MA200, a PM dust sensor, a meteorological sensor, and a microcontroller, together with a GPS and Bluetooth device for wireless data transmission. This is important to have real-time measurements, mobile measurements. Because if you want to provide direct feedback, these real-time measurements are needed. Furthermore, if you need citizens to link measurements with observations for them to have the aha effect, you need to use mobile measurement technologies. These real-time measurements, the citizens could check on their mobile phone. The data was transferred to server for archiving and further processing purposes. And there were complementary manual measurements with the sun photometer and some other devices to make more of the aha effect. The approach itself, what I wanted to come to increase the understanding of science for the public, it took several steps. Of course, first of all, you had to select the participants, and you started off this knowledge transfer and awareness building by one-day seminar on specific scientific protocols, how to collect data, how many hours per day, what is expected from the citizens, and how it will in the best case end up. During this workshop, it was also necessary to explain how the measurement kit works, where you can turn it off, how do you charge it, how the app on the mobile phone works. All these little tips were given within 3 hours. Then Air Quality Measurement Week started, and the non-scientist gathered data on black carbon and PM. They were going around for 1 week, doing on average more than 1 hour measurements per day. After this 1 week, they returned the backpack, and they could still have access via the project platform to their data, which was then accompanied by scientific data from more conventional air quality monitoring networks that are usually owned by the cities and by respective institutes like us. The citizens were then, they could monitor and associate their measurements with their observations and with official data from the authorities. There was scientific support provided throughout these steps. You could ask questions in forum. You would get people to ask, hey, my backpack is not working, or I went by a big old tractor and my measurement values, they peaked. What does this and that mean? You would usually have to give a reply within 1 day. So every citizen getting a backpack for 1 week is enough to do air pollution mapping with all the hotspots in Leipzig. Keep in mind, this is around 600,000 inhabitants. It's not one of the biggest cities. If you need to discover bigger hotspots, if you need to have bigger areas covered, you have to increase the hours of support you provide for citizens and the number of participants. Now we are going to the second approach. And this is the knowledge transfer within this citizen science project. You want to know, did you really capture that little element of getting the participants understand what is knowing and what is believing? And we recommend to measure that with questionnaires. You can have the same questionnaire giving to them before the approach and after the approach. And there you can record if they have learned something, how much they've learned, and how their attitudes toward science have changed. All in all, this setup, the goal is knowledge transfer, building awareness. So with these steps explained here on the figure, you can assure that for your project, for your research design. Now I'm going to follow the innovation and transform approaches. And I'm going to share you my experience based on TameBC project. So this was transdisciplinary black carbon mitigation research project that did not only happen in Germany, but took part in Manila, Philippines. Much more complex project, many more takeaways. Working on air quality management in Metro Manila, which is a huge, fast developing urban region, the research had to be designed differently, and it needed to take into account many more aspects. And the research setup described next is an innovative package of technological, socio-political, and health interventions for decision makers for institutional change to mitigate black carbon emissions. The first pillar in this framework, you have to start off with asking what you want to achieve and who is your target group, as with the previous setup. If you want to do in fast developing urban regions air quality improvements, you first of all need to record the state of the air quality. So we recommend that you start by doing out a measurement campaign. In the framework of TameBC campaign, this was in 2019 and 2020, a measurement container was employed to determine the particulate air pollution in Manila North Fourth and East Avenue. Within this transdisciplinary approach, technological solutions, they need to be planned and applied in cooperation with local partners. This is very important. The whole measurement campaign that we did, the technology selection process was always a collaboration with the local experts, with the local universities. The optimal technology selection should be made based on previous research still, and keeping in mind your goals and target groups, of course. But if no previous research exists, it can happen in the global south. It is suggested that the technology selection adopts well to world standards. Air pollution issues are more present in the global south. It is important to apply really state-of-the-art instrumentation that can be then perhaps developed remotely and does not necessarily need to be produced at the measurement locations, since economically less developed regions cannot afford the state-of-the-art, and there could be an issue of available expertise or resources to do high-quality measurement campaigns. The measurements and investigation stages executed in Metro Manila, Philippines, relied on the literature review, world standards, and on the methods that were proven to provide comprehensive information on the pollution properties. In the previous studies, also done in Metro Manila, also involving container measurements, estimating various emission factors. And this time we added also mobile measurements, as you can see on that little blue pillar. We measured black carbon levels in the port on a street level, did extensive literature review, and we set up a permanent black carbon measurement station. Manila, Philippines is much bigger area than Leipzig, so you can't send 100 people with backpacks out and hope you get a map of the whole city. Therefore, your target group is different and you need a different approach. Here we had several target groups, and we were not just interested getting the map of air pollution for the city. So we wanted to mitigate black carbon pollution. And I want to show you here on this slide where we carried out the studies, and as a comparison, how much bigger the region is, why you need a different approach than 100 volunteers going around for 1 week with a backpack. We needed to do much more, so we added other pillars to the study. And the pillar 2 focused on governments and institutions. The problem of air pollution was already institutionally assessed and recognized also by the government in Philippines in the 90s. Although the air quality measurements were not as detailed back then, they published Philippines Clean Air Act in 1999 to gain a deeper understanding of the institutional environment around air quality management in Philippines. Transform methodology, foresight, and backcasting methods adopted to follow the innovation were applied. These I explained in the previous slides. And on the one side, a content analysis of the regulations in place and how they evolved was conducted. On the other side, inconsistencies between the de jure and de facto regulations could be studied by understanding how these regulations are embedded in a wider institutional context on the local level. This means that also, besides policy review, interviews were necessary, and those were done with the people who were most affected. After policy analysis, it was necessary to build awareness on the negative health effects. This awareness building and health effects estimations for black carbon took place also in 2019 and 2020 in Manila, Philippines. This was also conducted in close cooperation with local partners, so hospitals, for building health awareness with regard to air pollution problems. The health component of the project aimed to increase knowledge of adverse health effects caused by ambient air pollution. The exposure of black carbon was measured for the main polluters, and ideally it has to be measured for several polluters and for those who are most affected. Measurements of black carbon inside local taxis called jeepneys was conducted using portable instruments. These are the backpacks that were also explained in the citizen science approach. So you can apply the technology, but it has to be complementary if you're dealing with bigger regions. And these mobile measurement kits should be used at different locations during different days and times to allow for more precise picture of the black carbon exposure levels for the drivers. And the drivers in Manila are the ones who are most exposed to the air pollution. Ideally, you are again also doing interviews, and you can also let them fill out a questionnaire. In this pillar, lifestyle and health conditions of the main polluters and those who were most affected were assessed using the burden of obstructive lung disease BOLD study questionnaire. The lung functions of the main polluters and those who are most affected were examined, and lastly, the association between black carbon and health outcomes was analyzed using linear or logistic regression models, depending on the classes of the outcome variables. Continuous or binary variables. And the approach itself is summarized on this slide. So we've taken the blue part, which is the air quality measurement campaign, the middle part, which is explaining how the policy assessment should be executed in a research design, and the last is health effects and awareness building. This is the medical sciences, how this should be integrated into the study design for sustainability. And last but not least, you have to add another pillar. When you want to adopt or embed something in a new region, you need to have a local coordination partner who takes the results from different pillars and make sure that these get embedded in the local region. And our local coordinator was responsible for applying all the results from the different disciplines in Manila. They have the access to different stakeholders, know the local culture, and only then your research results can really make a difference and make an effect. To sum up, what we can say is that your research design should always start with an outline of what you want to achieve, what's your research purpose, and who is your target group. If it's citizen science, use low cost, really easy to use sensors. There most probably you want to build awareness and break that line between knowing and believing, and give a bit to the citizens from scientific processes. It's a two-way learning and definitely knowledge co-creation, but it has one goal and one target group. You can use one simple set of low-cost mobile measurement sensors. But if you have several purposes and you have several target groups, you need to apply several pillars, take several disciplines and approaches, combine them. We therefore recommend follow the innovation and transform combined, as we did in TAME BC. And you can, with that, really contribute to black carbon mitigation and create institutional change towards better air quality. Civic involvement, once more, citizen science, institutional change, take the TAME BC approach, follow the innovation, which is co-creation, means you always have to have a local coordinator who works with all important stakeholder groups, and use the transform. This is well recognized sustainability research design for forecasting and backcasting for solutions and problems. So, as sustainability science is a problem-driven and solution-oriented field that follows a transformational agenda, we recommend transdisciplinary research. And transdisciplinary research in many cases is a promising choice, as it aims at bringing the gap between problem solving and scientific innovation. Today, I've showed results from two study designs, VT Impact and TAME BC. I've tried to make it as short as possible and presented how one could be applied in one way or another. I thank you.
Thank you.